So that actually gives me a whole new level of, I don't want to say respect, but when you were talking with Joscha Bach, which, by the way, I think that is one of the most amazing interviews I personally have ever heard, was your second interview with him. But every time I listen to a new interview with you, and we should talk more about your podcast because I'd like to get into that, but you were really harsh on GPT-3. And I've had some pretty advanced programmers on the podcast that have spoken pretty highly of GPT-3 and where it's going. So when you were pushing on that, saying like, it's not learning, it's just using a data set that's finite, and I was kind of like, well, who's this guy to be talking about the misgivings of GPT-3? But if you're out there doing your own learning algorithms, there's a whole new level of respect I have for you.
Yeah, I've been doing that stuff since, at least 20 years. I wrote one of the first genetic neural algorithms where we used Darwinian evolution to evolve neural nets and used it to create game playing agents.
That's the second time you've referenced neural nets, and I couldn't give a description of a neural net if somebody asked me.
Okay, well, most of the AIs that we're hearing about, the so-called deep learning type AIs, they are neural networks, which means that they are a very rough, cartoonish, similar to the way our brains are wired. That think of it as a whole series of nodes that have links between them. The links have weights. And let's say that, and there's layers of these nodes. So imagine 500 nodes in a line, then 500 nodes above that, and 500 nodes above that, and then each layer has connections to the next layer down. And in the general case, kind of the lazy case, all 500 in this layer are connected to all 500 in the next layer, but the weights differ. And not only do they differ, some are positive and some are negative. And so let's say the top level is where the input comes. So let's imagine in like this isnt problem I discussed. It's a very simple, I think it's 16 by 16 dots to exemplify the handwritten digit. So let's make 256 dots the top layer of the neural net. The digits that are turned on are 0, and the ones that are off are 1, or vice versa. Though actually MNIST, it's 0 to 255, but to keep it simple. And then that signal propagates down to the next level through these weighted links, and to the next level, to the next level, to the next level. Let's say the bottom level is just 10 nodes, which represent the digits 0 to 9. And the number of times or the strength of the signal being reached at that bottom node is the signal on which digit it is. So there's a really crude example of what a neural net is. And essentially everything you've heard about in AI, with some notable and I think important exceptions, is neural nets of one sort or another. AlphaGo, the great Go playing program, AlphaZero, the learning thing, GPT-3, they're all neural nets, all deep learning neural nets, which means they have many layers. When we first started playing with neural nets, say back in the 80s, typically they'd be 2 or 3 levels, maybe 4. Now they could be 100 levels, and they could be, instead of having 50 or 100 or 500 nodes in a level, they might have thousands. And in fact, some of the really big neural nets like GPT-3 could have billions of links in the model. So they're really quite remarkable. But they're not actually intelligent. They are, and this is what I was making the point with Joscha, that they are a statistical learning model. They have made a whole series of little bit at a time adjustments to these weights until they give the right answer, at a high level of probability. But that's all they are. GPT-3 does not understand the English language, though it can do some remarkable things that can fool people into thinking that it does. And it's really, but it is a quite useful tool as long as you know what it's good for and what it's not good for. For instance, you would not want to use it at this stage for medical diagnosis because it is this neural net. It isn't always right. Some percentage of the time, it'll give you absolute nonsense. It's a small percentage currently, but it's there. So it doesn't actually know anything. It doesn't actually understand English. What it is a collation of the learning from looking at probably billions of words of English that Google has, not Google, the other guys, OpenAI has scooped off the internet and processed. and created this static representation. That's the other thing about GPT-3. It does not change. Once you start using GPT-3, it learns nothing from your use of it. It's essentially this distillation of the billion things it has read. So the reading happens, it creates this artifact, which then does its GPT-3, but it doesn't learn anything from interacting with you. Hope that's helpful.
Oh, that's fantastic. The first question that comes to mind when I think about these things, and I spoke with Ken Stanley, who's at OpenAI, is as you're building these computers and you're making them smarter and smarter, and you're adding in a learning algorithm so that they can actually teach themselves. Do you fear, or is this just the fear of us plebeians or normies, of a runaway AI, a system that's so smart that we can't control it or don't even really understand what it's doing?
Yeah, this is the so-called AI risk discussion. By the way, Ken Stanley is one of my heroes because he's one of the people who has also done, in fact, he's done more interesting work in evolutionary neural nets than anybody else, I would say.
Oh, Ken Stanley changed my life. I read his book on the Why Greatness Can't Be Planned, the novelty search, and that idea led me into a whole different way of thinking. Between him and Joscha Bach, they're heroes of mine for sure.
Yes. Most of my work originates from the University of Texas neural evolution work, and Ken Stanley is one of the students of that work. And so he's in that tradition, and probably the person that's pushed it the furthest, at least in terms of actually useful tools. But anyway, getting back to AI risk, it's funny, I talk about this fairly regularly. I was talking with one of my good buddies, Ben Goertzel, yesterday. In fact, he's the guy who coined the expression AGI. And he's created an AGI framework. He's written 15 books on the topic. And we talk about this regularly. And we both believe that, yes, in the long run, there is risk that an AI could take off the so-called technological singularity. And this is a very important concept. And in the simplest form, let's say the following. Let's say you finally get an AI that's a teeny bit smarter than a human, say 1.1. And let's suppose you give it the job of designing its successor. And the successor it creates is 1.2 as smart as a human. And then you say, I'll give that one the job of creating its successor, and the next one comes out at 1.5. And then the one after that, 1.9, the one after that, 3.3, and then 10, and then 50, and then 1,000, and then 10,000, and then 1,000,000. So it's conceivable, and there is a theory that could all happen in 6 or 8 weeks once you reach the takeoff threshold. Now, there are people who argue on, where is the takeoff threshold? You have to get to 1,000,000 first before it's dangerous. I'm not sure. I don't think anybody knows the answer. But in terms of whether the work they're doing today, like GPT-3, is dangerous, I'd say absolutely not, because it's not. It's a static artifact that's been created. It can't continue to learn. It doesn't have any consciousness. It doesn't have any sense of self. Frankly, it's no more different than an oscilloscope. Basically, you put data in, you get something out. But it's something that those of us who are working in this field need to be aware of. And at some point, we'll have to become more proactive in building AI safety into what we're doing. Of course, Nick Bostrom's book, what the hell's the name of it? I don't remember, but is the place to start to read about AI safety. And MIRI, MIRI.org, has got some of the most cutting edge people thinking about AI safety, but realize they're in the AI safety business, so they're kind of overhyping it a little bit, in my opinion. So, but anyway, those are two good places to look for those who want to learn more about AI risk and AI safety.
Thanks for checking out this podcast short. If you like this interview, make sure you hit the like and subscribe button and hit that bell so you always get notified about this podcast. And if you're really interested in conversations like this, you may want to consider joining the Articulate Ventures Network. To find out more, go to network.articulate.ventures.